So today we'll talk about our next set of instructions. So as you probably noticed that we have been exploring new instructions almost in every class. So these are some new kinds of instructions. Again, it's probably worth to mention that these are pretty different than most of the instructions you have seen so far. So these are called shift and rotate instructions. Let's look at what these instructions are and how this instruction work. So we'll first talk about some instructions called logical shift instructions. So if you look at your instruction set, you will find these instructions. For an example, you have LSL, LSLA, LSLB, and LSLD. So as you can guess from this instruction, you can guess that one is for A, one is for B, and one is for D, and this is for the memory location. So what you can do is by the logical shift left, you actually can move all the bits of accumulator A or any byte to left, one position. Okay. So for an example, if you look at here the example, let's say you have a byte. Now it might be your accumulator A, might be your accumulator B, okay, might be a memory location. So if you do the logical shift left, what happens is you will be actually pushing a 0 from the right side. So basically you will be pushing a 0 to the least significant bit, the rightmost bit, and whatever you will have, so every single bit will actually be moving one position to the left. So the very leftmost bit that you have in the bit number 7 position will actually go out of the byte and will be stored into the carry. Okay. So same is here, shift right, you do the similar operation but the backward, meaning you'll be pushing a 0 from the right side to the bit number 7 position, and every single bit will be moved one position to the right, and then the bit that you have at the very rightmost side will actually go to the carry. Now this is actually an exception than what we have talked about the flags in last class. Remember we are talking about the carry and borrow flags, and we know that the carry flag can be set in the addition operation and also in the subtraction operation, but here is an example which is like an exception where we are not doing any addition or we are not doing any subtraction, but we still have a carry based on the operation, meaning you may have a carry one set or you may have a carry cleared based on the byte you have. So we'll show you some example. Now we have, for an example here as an example, let's say we are trying to apply LSRA, which is the logical shift right for accumulator A. So let's say you are given the content of the accumulator A, which is FF. So that is given, right? So we just want to know what will be the content of the accumulator A after you execute this instruction. And as you can guess from this instruction, this is an inherent instruction, right? Because there is no operand. It doesn't actually need an operand because all you are just saying that do the left shift, I'm saying the logical shift right for accumulator A, right? So automatically whatever the content you have in the accumulator A, the logical shift right will apply to accumulator A, so there is no need of any operand. So you understand probably why it is inherent. Now let's say this is what we are given, right? So the content of the accumulator A is FF, that means 8 ones, right? So you have this one at the beginning before we start executing the instruction. Now we know that we are, because of this instruction, we are going to push a 0 from the left side, and every single bit will be moved one positions to the right, and at the end whatever you have here at the very rightmost, meaning the least significant position, will actually go to the carry. Now let's do the operation. Now once you do it, you see the changes, right? You see we pushed a 0 from the very left side and all the positions are moved actually one positions to the right. It may not be visible every time because it's all ones, but the very rightmost position, whatever you had here, is actually pushed out of the byte to the carry. So if you are asked what will be the content of the accumulator A right now, your answer would be 7F, right? Because you see here the first, this is my 7, 0, 1, 1, 1, that's my 7, right? And 1, 1, 1, 1, that is my F. So the new content of the accumulator A is 7F after you are done with this instruction. Any question? It's actually easy, but it's a different kind. I'm saying we have tried a lot of different instructions by now, but these are something quite different than most of the instructions. Let's try something called arithmetic shift operations. Interestingly, arithmetic shift left and logical shift left are exactly the same operations. Okay, so arithmetic shift right is a little bit different. So as you can see, we have arithmetic shift right for A and B and for the memory locations. So this is the interesting part. So it shifts all the bits towards the right, but it retains the original value of most significant bit. So basically, it's not, you are not pushing anything from the outside. All you are doing is you are retaining this bit, whatever you had in the most significant position, and then you are pushing everything else one bit. Or maybe you can think like this. That's also easy for me. What I do is, whatever I have in the most significant bit position, I actually push that. That's the same idea, right? So basically, if you have 0 in the most significant bit position, that means you are pushing a 0 from the left side. If you have a 1 from the at the most significant bit position, you are actually pushing a 1, okay? And every single bit will be pushed to the right, and the very rightmost bit, which is the least significant bit, will go out of the byte to the carry.
Sorry, in that bottom example, so for that box that has the arrow sort of circling around and pointing.
This one?
Yeah, so that box would have a 6 in it usually.
Oh, this is 7.
7.
See, because we start counting the bit number 0, right?
Yeah.
So there are 8 bits. We count from 0. So these are the bit positions.
Yeah.
So this is the 6th position, and this is the 7th position.
Okay.
Okay. So we always count from 0, and we go all the way up to 7. That's like our 8 bits, right, in a byte. So let's look at an example. But before we go there, let me clarify one thing, because as I mentioned that arithmetic shift left is equivalent to logical shift left. So you might be wondering, so why we need these two instructions then, since they do just the same thing, okay? Because their purpose is pretty same. The instructions are indicated to make some programs clearer, programs clearer, because sometimes there is a set of instructions for, there are instructions for arithmetic ones, there are instructions for the logical ones. So the programmers actually try to keep it meaning separate, like logical shift and arithmetic shift, but technically there is not much of a difference, okay? Because as you have seen, the operation is pretty same. But they sometimes try to keep the convention, okay? Now, here is an example for arithmetic shift. So let's say we are given the content of accumulator B, which is 8B. So this is given, okay? Now, what will be the content of the accumulator B after you are done with this arithmetic shift instruction? This is again an inherent instruction, right? This is inherent. There is no operand, and you probably can see the justification why it is inherent, because you are trying to do an arithmetic shift right for accumulator B. So basically, all information you need, you got it. So you don't need any operand, because you will be applying this operation on B. Now, so this is what we are given, right? So we are given the data is 8B. So basically, this is my 8, right? 1, 0, 0, 0. That is my 8. And this is my B, right? 1, 0, 1, 1. That is my B. Now, again, how do I do the arithmetic shift operation? We actually repeat this one, right? So basically, what we do is, since the leftmost position is 1, you can think we are pushing a 1 from that side. Okay? And then every single bit will be pushed one position to the right, and the very rightmost position, meaning this one, will go out of the byte. So let's do that. So you probably can see what happened. This one was repeated here, but every other bit was pushed one position to the right, and whatever you had at the very rightmost side was actually pushed out of the byte to carry. Okay? So the idea is actually very simple. The only difference is these are different kinds of instructions.
So
right?
the carry becomes the first bit? Is that what you're saying?
Whatever you had here, that becomes still carry. Because you pushed everything to the right.
Yeah.
Except this bit was repeated, meaning whatever you had here, so basically whatever you had here, that was repeated. Let me show you again. See? This bit was repeated, okay? And then everything else was pushed one positions to the right, and then whatever you had at the very rightmost corner, that meaning least significant bit position, that went out of the byte to the carry, okay?
Gotcha.
There are plenty of exceptions like this, because even if we mention, oh, carry flag is set for this reason, but now you can see the carry flag is set for several other reasons as well. Okay, and these instructions are not addition, these instructions are not subtractions. Okay, but we don't want to tell all the exceptions at once. We'll know it over the time. Any question here? So the answer, after we are done with this instruction, what is the content of accumulator B? So my answer is C5, right? How do I know it? So look at this. This is my C, right? 1 1 0 0, that is C, and 0 1 0 1, that is my 5. So that is what I got from here. Any question? All right, so let's try another type of instruction. These are similar but a little bit more exciting. So these are called rotate instructions. So instead of just shifting, they actually rotate all the bits. So this is how it works. I think as you can guess from here, so all bits including the carry are basically rotated. Okay, so that means the carry goes all the way to this side, to the right side, and every single bit is pushed to the one positions to the left, and most significant bit that we had here goes to the carry. So basically it's like a circular rotation, one position, okay, to the right, and I'm saying to the left. So this is to the right, okay. So idea is still same. The only difference is to the right and to the left. And as you can see, we don't have rotate left or rotate right for accumulator D. We have one for accumulator A, one for accumulator B, and one for memory location. So basically all of these are for 1 byte, right? So 1 byte of destination. So let's try an example. Let's say one thing that you need to clear, if you are really trying to understand the rotate instruction, you actually need to know what you have in the carry before you do the rotate instruction, because carry is actually part of it. Look at this. You need to know this carry before you even start, because this carry is actually pushed back all the way to this side, right? Same is here. You need to know the carry so that you know that what is going to be pushed from the left side. So that's why whenever we have a question for the rotation, we'll also tell what is the carry flag right now, because you need to know this, otherwise you cannot find the answer. So in the question we are told that the accumulator B, we have the content here is BE, and the carry flag is set at the beginning, okay? And then the instruction we are going to try is RORB, that means rotate right for accumulator B. And again, this is an inherent instruction, as you can guess. So this is my accumulator B. So this is the BE, right? So as you can see, this is my B, 1011, that is B, right? And 1110, that is my E. So I have my BE here. And I also know from the question that my carry flag is 1, right? That is given. Carry is set. Okay? Now, to start the rotation, this is how it will work, right? We'll push every single bit to one position to the right, and this bit here, this very least significant bit here, will go to carry, right? And the carry will go all the way to the beginning, right? Because it will be like a rotation. So let's try that. The rotation is done. Now after the new rotation, my content of accumulator B is changed, and the carry flag is also changed, because the rightmost bit was 0, so now the carry is 0, right? So if you try to answer this question, meaning what is the content of accumulator B, the answer is DF, because you probably can see from here, this is my D, 1101, that is my D, and again 41 is F. So the new content of the accumulator B is DF. Any question? So it's too easy, right? Okay. All right, so that's a different kind, but I'm sure that is easy. Once we practice a little bit, we'll understand it. But again, the idea of exploring all these instructions, because at some point you will see that everything that we are learning in different places, different quizzes, different lectures, this all will come together in one place, and I'm sure that we cannot wait until that point, but we have to wait a little bit. So we'll get there, okay? So let's try our next quiz. This is just one quiz where in every question you will be given the content of either accumulator A or B or D. In some questions you might be given the carry flag because that is like rotation. You need to know the carry flag, and then you just have to apply the operation and just tell us what will be the content of the register, meaning the accumulator A, B or D. Let me stop this presentation here so that we can go to the quiz section and try our next quiz, which is quiz 8.